Hi guys, and welcome to the first lesson of Chapter 5, Solving Inequalities. Now a bit of housekeeping before we get started. This chapter right here, these numbers, 5.1 and 5.2, these are the book chapters and sections. Okay, so if you go to your book, this lesson is Chapter 5, Section 1, and actually it's Section 5.2 and 5.3. We're going to learn a lot in this lesson. You would have seen that this assignment is labeled as 4.1. Okay, so this is our online day 4.1. Okay, so in Unit 4, we are talking about Chapter 5. Okay, so for those of you following along in the book, that's what's going on here. But back to the lesson, we will be talking about how to solve inequalities by addition, subtraction, multiplication, division, and then at the end, we're going to get into some multi-step inequalities. So a lot to do today. Now, as a reminder, inequalities is an open sentence that contains any one of these symbols. Now, you've probably seen these symbols before, but we're going to go over it one more time. These are less than, greater than, less than or equal to, and greater than or equal to. Now you've probably heard a lot of different strategies about how to tell which one's which. Some favorite of mine from middle school are the alligator mouth and or the Pac-Man mouth. And whichever way the mouth is facing, that one is greater. Okay. However, we're in high school now, so things are going to get a bit more complicated. It's really important you know how to read these symbols. So whenever you go to solve, whenever you go to write your equations or to graph them, I'm going to tell you, always read the sentence out loud. That'll help you keep in mind which one is which. So down here, problem number 1, example number 1, you would read this as x is greater than 1. Now one of the main ways we represent inequalities is to graph them. Okay, these can be graphed on a number line, which we're going to do right now. A little later on, we'll get to graphing them on a coordinate plane. Okay? But right now, we're just sticking to number lines. Before we get started, though, a few symbols. The greater than or less than, whenever you graph that as an open dot. Okay? If ever you are including the point, so less than or equal to or greater than or equal to, you're going to do a closed dot. Okay? What this open dot means is that you're not including that point. That point or that number. Okay? If you have a closed dot, that means you are including the number. So when we go to example number 1, we would graph this like this. So a couple things to notice about my number line. The first thing is I only included the number that x is greater than. Okay, I included the relevant number, you could say. All right, if you want to include more numbers on your number line, if you want to have 0 or other numbers, that's fine, go for it. But I will only require you to have the relevant numbers. Okay. Number 2, my symbol is greater than, which means I'm going to have an open dot and that all values of x have to be bigger than 1, so they are over in this direction over here. So 2 is greater than 1, 10 is greater than 1, infinity, or just pick a smaller number, 80 is greater than 1. Now let's try the next one. This one is x is less than or equal to negative 3. So again, I'm only going to include the relevant number. My symbol is less than or equal to, so I'm going to have a closed dot. Now, x is less than or equal to, so that means it's going to be values that are smaller than negative 3, so my arrow is going to go in this direction. Now that we've gone over that, let's move on to solving these things. So solving inequalities is a lot like solving normal equations. There is a big twist, but that comes up when we start multiplying and dividing. Right now we're just going to start with adding and subtracting. So when you're adding and subtracting, you're going to use the exact same rules of normal equations. So you're going to get x by itself on one side of the inequality symbol and move everything to the other side. So let's start with this first example. I have x minus 12 is greater than or equal to 8. So I'm going to add 12 to both sides. And now I have x is greater than or equal to 20. And I can graph this quite easily on a number line. I have 20. X is greater than or equal to. So it's going to be a closed dot. And my arrow is going to the right. Now, this phrase behind it, check your solutions. When you want to check your solutions, you're actually going to plug in 3 numbers. You're going to plug in a number that is smaller. You're going to plug in the number itself. And then you're going to plug in a number that is bigger. The reason why you have 3 different numbers is you're checking to see if your arrow is going in the right direction. So when we go to plug these in, I'll do the 10 first. So is 10 greater than or equal to 20? Of course not. 10 is not greater than or equal to 20, so our arrow should not be going in the direction of 10. Next, we check if the dot should be closed. Is that a true statement? Okay, so we have 20 greater than or equal to 20. Well, yes, 20 is equal to 20, and so that works. So our closed dot is correct. Lastly, you're going to plug in 30. Is 30 greater than or equal to 20? And yes, 30 is greater than 20. That works. Okay, so this is just how you check your graph. We should have a closed dot, and our line should be going to the right, which it is. You guys go ahead, solve the next one, make sure you graph, and make sure you check the solutions. And here's the solution. If you had difficulty with this, particularly the graph part, remember 2 things. 1, always read them out loud. So this one says 6 is less than or equal to A. So 6 has to be less than A. And that means that A is going to be bigger than 6, which is why our arrow is going off to the right. If that doesn't really make a whole lot of sense or is still confusing you, again, this is why we check our answers. Pick 3 values and check them out. Is 6 less than or equal to 5? No, it's not. So the graph should not be going to the left. And then the other 2 values check out. Now, this little note off to the side that you may or may not have noticed by now, set builder notation. Now, we've already talked about set notation when we did absolute value. So remember, a set indicates a list of numbers. And as you can tell from our answers over here, x is not equal one specific thing. Okay, it equals all numbers greater than 6 or greater than 20. There's a lot more numbers in there than just 1. And so the appropriate way to write your solution would be in set notation. And you're going to use this format right here. So curly brackets, x, then you have this bar kind of a thing, very similar to the absolute value bar. And then you write your inequality. So x is greater than or equal to 20, close curly bracket. Now, the way you read this is x such that x is greater than or equal to 20. And so if ever I say write your answer in set build notation, you would just do this. Whatever the variable is, a such that 6 is less than or equal to a. That's all it is. Now you guys go ahead and do these. And not only do I want you to graph your solutions, but I also want you to check them and to write the answers in set builder notation. All right, go ahead and get started. and here are your answers. If graphing the inequalities is still throwing you off, remember, say the inequality out loud, talk through what that means, and then check your answers. Pick a number that is beneath it, that is less than it, pick the actual number and the number that's greater than it, and see which ones work. The arrow has to go in the direction of the ones that work. Now, whenever you multiply or divide in an inequality, that's when things start happening that's different than a normal equation. Okay? So as you can read in these examples and see in these examples, that whenever you multiply or divide by a positive number, the value of the inequality remains the same, and the direction remains true. So if you look at this first bit, I have 4 is greater than 2. Well, that's correct. If I were to multiply a positive 3 to both sides, I would then have 12 is greater than 6, and that is still correct. However, if I were to multiply or divide by a negative number, things change. So if I were to start off with 7 is less than 9, and I were to multiply each sides by -2, the inequality symbol would have to flip to keep the sentence true. So -14 is greater than -18. Notice how the symbol flips. Okay? Otherwise, you would have had -14 is less than -18, and that's just not true. Okay? So whenever you multiply or divide by a positive number, you don't have to worry about anything changing. But when you multiply or divide by a negative number, you have to remember to flip the sign. Otherwise, your answer is going to be incorrect. Now let's practice. So for this first one, we have a fraction. N, or negative n over 6, is less than or equal to 8. So you solve the way you normally would solve. So I'm going to multiply both sides by a -6. And that leaves me with n and a -48 on this side. However, since I multiplied by a negative, I have to flip my sign to go the other way. Now let's do the next one. So again, we have a negative fraction. So I'm going to multiply both sides by my denominator. And this time I'm going to multiply both sides by a +3. You could do a -3, but just to give you the other side of the example, I'm going to do a +3. So now I have a -4p is greater than -30. Now I'm going to divide both sides by my -4. Okay? Since I divided by a negative number, in my next step I have to flip my sign. And I have -30 over 4. +30 over 4, because a negative over a negative is a positive. Now always make sure you simplify your fractions, and p is less than 15 over 2. You guys do the next one and pay attention to if the sign flips or not. Since it was a positive number that you were dividing, you did not have to flip the sign. Just make sure you simplify your fractions. All right, now that you know the rules, let's try some more complicated problems. Now I'll do the first one with you, and the second one, you'll do the third one on your own. So let's get started. Number 1, you're going to start off the exact same way you would a normal equation. So I got to get b by itself. I'm going to add 3 to both sides. 8b is less than or equal to 56. And then I'm going to divide 8 from both sides. And b is less than or equal to 7. And because my instructions say put my answer in a solution set, that's b such that b is less than or equal to 7. On to the next one, number 2. Okay, so I have a fraction. Don't be scared off by fractions. We know how to do this. I'm going to multiply both sides of my equation by a 6. That way I can get rid of my denominator. So my denominators cancel. And I'm going to simplify. Now, because I'm multiplying by a positive number, my sign stays the same. Now I'm going to add 8 to both sides, and that is -4 is less than or equal to n. Put it in set notation, and we're done. Okay, you try this next one. Remember to distribute first and pay attention to your signs. Go for it. And here's your answer. Remember, when you distribute, you're distributing the -6. So that's going to change the numbers inside to a positive 12n and a negative 48. After that, just be careful with how you add and subtract. Since we did not multiply or divide by a negative number, our sign stays the same. All right, we are almost done. Next thing I want to go over is the real and empty sets. So think back to when we were solving equations, and every so often you would have an equation where the answer was either all real numbers or no solution. The same thing is true of inequalities. So if the inequality results in a statement that is always true, then the set is going to be all real numbers. If the inequality results in something that isn't true, then you're going to have an empty set. And you can write that as a symbol of the 0 with the slash through it. Okay, that is the symbol for the empty set. So let's solve these two problems and see an example of each. Now this first one, don't forget whenever you have a long equation like this, always address your parentheses first. So I'll be distributing a -5 into my parentheses and a 4 into these parentheses. So that's 9t minus 5t plus 25 is less than or equal to 4t minus 12. Then combine like terms before you do anything else. So this is 4t plus 25 less than or equal to 4t minus 12. You may be already able to see where this is going from here, but I'm going to finish it off anyway. So I have subtract 4t from both sides, and I have 25 is less than or equal to a -12. And this is obviously not true. 25 is not less than or equal to a -12. Therefore, we have an empty set. Now let's go on to the other one. Again, address your parentheses first. So I'm going to distribute the 3 in and the 6 in over here. So that's 12m plus 18 is less than or equal to 42 plus 12m minus 24. 12m plus 18. Combine like terms over here. So 42 minus 24 is equal to 18 plus 12m. And you can probably see where this is going from here. We have the same exact thing on both sides of our equation. But I'll solve it out so you can see what happens. So subtract 12m from both sides. And I have 18 is less than or equal to 18. Now, don't let the inequality fool you. Read the sentence. 18 is less than or equal to 18. Now that's a true statement. 18 is equal to 18, and so our solution is all real numbers. And the way you would write that is m such that m is all real numbers. And to do the fancy R, it's 2 bars down and then an R over like that. Last thing we gotta go over is everybody's favorite topic of word problems. Inequalities have a lot of word problems. Inequalities pop up everywhere in the real world, so there's a lot of real world examples. For instance, if you're going to the mall and you have $65 you can spend in total. All right, he bought a t-shirt for $18 and a belt for $14. If Sanjay wants to buy a pair of jeans, how much can he spend? Now the first thing you got to do is translate it into a math sentence. Don't try solving things off the bat. Just translate it first. So if he wants to spend $65 at the mall, so 65, that means he can't spend anything over it. So x, our unknown value, cannot be greater than 65. So 65 has to be greater than the rest of our equation, greater than or equal to, because we can spend $65. He bought a t-shirt for 18 and a belt for 14. If he wants to buy a pair of jeans, how much can he spend? So 18 plus 14 plus our jeans, what is it? So we have 65 is greater than or equal to 32 plus x. Subtract 32 from both sides. And we have that 33 is greater than or equal to x, meaning that the most he could spend is $33 more. Okay, you guys try this next one. First, translate it, then solve. And there it is. Now this first line, I wrote it a little spread out so you could see how each part of the sentence translated directly into the inequality, and then I wrote it more normally to solve it. Okay, that is the end of this video. Let me know if you have any questions, and I will see you in class.